Hello and welcome to our webinar today. Today's topic will be energy flow management with Fronius inverters. And joining me is my colleague Byron Coates, is the TSA or Technical Sales Advisor for Southern African region. And myself, David Mwangi, I'm the Technical Sales Advisor for the Eastern African region. Our agenda for today, we will look at the energy management possibilities with the digital IOs, the 4 digital IOs within the Fronius inverters. We will talk about how to maximize self-consumption. We will look at storage with Gen 24+. We will also discuss the Ohmpilot as well as the Wattpilot. So as usual, if you have any questions, please feel free to type them in the questions area, and then we will answer the questions as we go along. In addition to that, if you have any specific feedback regarding the webinar or any topics that you would like to be covered in future, please also let us know. You can use the feedback functionality or reach us by email as well. So let's get started and look at the energy management with the 4 digital IOs. So when you talk about energy flow management, we are starting from a point of view whereby you have installed a PV system, of course, with a smart meter so that you can see the exact power flow or energy flow within the setup. And this allows you then to do load profile analysis to see exactly what is consuming the energy that you're generating, or if you're consuming also from the grid, what is the portion of the energy consumption from the grid. With this information, then you are in a position to do load management. And therefore, when it comes to heavy loads, you can very specifically or very closely be able to manage how these heavy loads are consuming power within your network. So therefore, it means to integrate things like battery storage or generating hot water and even EV charging would be possible once you have an overall picture of your entire energy consumption, and therefore you achieve very good energy flow management. So in terms of the control options, we have 2 key control options. One is what we are referring to here as load management, which can be achieved by use of the 4 digital IOs that I've just mentioned. And here the purpose would be to increase your self-consumption, which therefore would trigger an on signal, and then also reducing the peak loads, which then means that you turn off something that would consume outside of your, let's say, PV generation. And then you have the possibility also as a control option for dynamic power control, which means that you are able to do stepless control of the surplus power. And this then can be fed into a battery storage or use that to generate hot water using the Fronius Ohmpilot. In addition to that, you can very specifically connect a Wattpilot for EV charging, and then you also have the control of surplus energy from the inverter. And therefore, the purpose here would be likewise to increase the self-consumption and avoid peak loads in combination with battery storage, because the battery storage can also offer you, whenever possible, to use a battery storage system, can also become a buffer so that if you have a load that is consuming more than the PV production at that particular moment, then whatever balance of power is required can actually be taken out from the battery storage before you go on to consume any element of power from the grid. In terms of the benefits of energy flow management, so the key benefit would be to increase your own consumption of what you are generating, and therefore increase the self-sufficiency. It would allow you to use cheaper nighttime tariffs, and especially if you have what we refer to as time of use tariffs. If you do recognize that you have, or you realize that there are some times of the day whereby the tariff is cheaper, then you can program your utilization of this energy in a manner that you only use what is cheap or cheaply available from the grid. So therefore, it means by using this kind of energy management, you are able to avoid expensive grid power. And in terms of installation, it's a standard. These are very simple installation with standard components, and no control devices in addition are required. So when it comes to the management using the 4 digital IOs, so as you know, every Fronius inverter has these digital IOs integrated. So if it's the snap inverter with the data manager, then you have these 4 digital IOs, which give out a 12-volt DC signal. And this is integrated as standard, like I said, provided you have the data manager within the inverter. So with these 4 management outputs, 4 energy management outputs, you can control things like an EV. You can also control air conditioning and then a pool pump, in addition to other big consumers like water heaters. When it comes to the wiring, so specifically here looking at the snap inverter, you have the same connection area where we do the connection for the smart meter. So you can see here to the right, bottom hand side, we have an orange plug where we have the connections for Modbus RS485. So within the same plug, we have the 4 outputs, which are position 0 up to 3. So we have 0 and then IO1, IO2, and IO3. So this can be used to control the 4 loads that I have just mentioned before. When it comes to the Gen 24 Plus, so the same kind of configuration is possible. So the only difference here is that the Gen 24, instead of the data manager, is using a pilot. But in terms of the available outputs, we still have 4 of them. So you can see them starting from IO0 to IO3. So the connection diagrams for both the snap inverter and the Gen 24 are very similar. So you can see here, you are connecting from any of the IOs. So we have, for instance, here a connection from IO1 and a negative connection that is used to activate an external relay. So this relay then would connect any of these loads, whether it's an electric vehicle, pool pump, it could be, or even a heater. And whenever there is excess energy available, then the inverter through the IO allows the relay to close. Once this closes, then this particular load is able to utilize whatever excess energy is available from the inverter. What you can see here is also an inclusion of a manual switch, which would allow you to bypass the relay, so that if you do require this particular load to get into operation at any moment, then you have this possibility using this manual bypass switch. So for the Gen 24, a very similar schematic, so very similar to the connection of the data manager with the snap inverter. When it comes to the external relay that is required, we have some examples here. So this is not exclusive. So these are just examples. So we have the feeder relay, for instance, and the Vedmura relay, and the technical specs. We have what you're getting from the pilot or the data manager is a 12-volt signal and a maximum of 3.2 watts. So what you should connect in this particular area here is only a 12-volt relay. Relay should not be either 24 or 240 volts AC. That is not going to work with the digital IOs. When it comes to the configuration, for you to activate now the IOs, you have to activate the Wi-Fi access point of the inverter. For instance, this shows the activation of the data manager's Wi-Fi access point. And then you follow the procedure for connecting to this Wi-Fi access point. And then lastly, you would have to enter this IP address, which is common for all Fronius inverters. It doesn't matter whether it's a snap inverter or a Gen 24 Plus. So 192.168.250.181. And then you are able to connect to the web user interface of that particular inverter. Once you have activated or connected to the web user interface of the inverter, if it's a data manager, then you'd go to the IO mapping section, and this IO mapping would then allow you to activate any of these outputs. So we have output 0 up to 3 here, and then you can see here the descriptions. So all of these can be used for load management. So once you activate, you can assign what exactly are the thresholds for activation for that particular IO, depending on the portion of excess energy that is available. So in details, then you have to assign, for instance, here for this example, you can see that we have, just to try bring it closer for you, we have here a load management for IO1, where we are saying that for the last 250 watts, this is the operation behavior that we want. We want to control this by surplus, and this is a very good option when you have feeding limits, so that in most African countries, we are not allowed to feed PV power to the grid, and therefore it's a very good idea to look at how you can utilize all the energy that you're generating. And one of the ways is to now assign these thresholds. So you can see here, the last 250 watts, we are going to activate a certain load that is connected to a specific relay that is switching it on and off. And then we say that our activation point, which is on, is when we have surplus energy of about 250 watts available. And then our off thresholds is when we start consuming about 100 watts from the grid. So we can go in this manner and assign all the 4 IOs. And then we have to set, very importantly also, what is the minimum duration per on signal, so that this would prevent too many on and off cycles of that particular load. So that if it's a pool pump or something like that, you might want to say that whenever I put on the pool pump, I want to run for minimum 5 minutes, regardless whether there is excess energy or available or not, and then switch it off within 5 minutes if I'm consuming a certain amount from the grid. You also have to specify what is the desired duration per day, like how long that particular load should be on the whole day. And if it's something that has to be finished within the course of the day, you have to set also a finish by time, so that if you want to be sure that you are going to use as much PV energy as possible, then you set your finish by time to a period whereby you will still have solar irradiation. So like I said, you can proceed like that and be able to set for the operation behavior for all the 4 IOs. It's very, very important also to do the energy management priorities or prioritization. So here we can see that we have the possibility to prioritize from the battery to the Ohmpilot and then the load management IOs. And as we can see here, the description of the legend, it says here that number 1 has the highest priority, number 2 is medium priority, and number 3 has the lowest priority. So what basically this means is that when you have the battery as the number 1 priority, any available surplus energy will go to the battery first. And if the battery is satisfied as far as charging is concerned, then the Ohmpilot takes priority number 2 to utilize the excess energy. And if the water temperature has been achieved, then the management of loads through the IOs will be priority number 3. Of course, if you do not have a battery system or an Ohmpilot and you want only to use the management IOs, digital IOs, then you can flip this over so that you have the load management IO as your priority number 1 for using the excess energy. Okay. So as far as prioritization is concerned, so what I should add in addition is that the prioritization will switch on from the lowest threshold to the highest. And if 2 loads have the same switch on threshold, then they will be switched according to how they are listed in that particular prioritization area. So the load that is higher on the list would start first, regardless whether they have the same starting or switching on threshold. So very important, once you have done any changes within that load management or IO mapping area, to always save the settings. So do not leave that area without clicking this tick button. So that affects the settings that you have done within the inverter. So we can see here some examples of thresholds settings. So we have two examples whereby we have a threshold setting with the small grid consumption, and this is something that would be preferable with a big load. So we can see here that we have this load switching off when you have consumed about 1,000 watts from the grid. An example could be an EV charger. And then we have an activation threshold of about 3 kilowatts. So if you have 3 kilowatts of excess energy available, we are switching it on. And then once we start consuming about 1,000 watts from the grid, we are switching off at this point. Another example could be a threshold setting without grid consumption. And this is preferable with smaller loads. It could be something like a pool pump. And therefore, we have an activation threshold once we have about 1,000 watts. And if we have no surplus energy, then we are saying to the inverter, we do not want this load to be operating and therefore consuming from the grid. So at this point, we are switching it off from the 0 point. So we have no consumption at all as far as this load is concerned from the grid. When it comes to the runtimes, like I said, you have to define what is the minimum runtime, so it prevents too many on and off operation of the load. Maximum runtime, so this is the runtime limit per day, so that if it's something like a pool pump, there is no need to operate it for more than 8 hours per day. So here you have to decide how many hours of operation, for instance, if it's a pool pump, would be enough to turn over the entire volume of the pool so that you have all that filtered and cleaned. And in addition to that, if the pump has been operating for several instances on and off, maybe 20 minutes on, 30 minutes on, and so forth, those would be added to sum up to what is the required runtime limit per day. And then what is the target runtime? So this means by what time the particular load should have finished operation. And therefore, like I said before, if you want to be sure that you are only going to consume as much as PV power as possible, then you set the target runtime during the period where you still have PV production. So let's now look at some application examples. We have example number 1 here. We have prioritization of 3 loads. So we have here priority number 1 with a pool pump, which we require to operate for about 3 hours per day. Then after that is finished, we want to feed power to the battery. And after the battery is satisfied, we want to feed power to the Fronius Ohmpilot. So you can see here that the operational threshold of the pool pump is at around 1,000 watts. And once the pool pump has finished operation, as you can see on this scale, we want then the battery to start charging. And once the battery is now fully charged at this point, all the excess energy would then be transferred to the Ohmpilot for heating water. So you can see that even with this kind of prioritization and load management, we still have quite a bit of excess energy available, which you can see here in green. So this means that this is power that would most likely sit idle on the roof, because like I said, in most African countries, we are not allowed to sell this portion of power to the grid. So it means that you are losing on quite a bit of PV production there. Example number 2 tries to take care of that, and we have several combinations here. We have priority number 1, which is the digital I/O. So we have a pool pump that is running for 3 hours per day. We have another load that is controlled by digital I/O2, which is an EV charger. So this has an activation threshold of 3,000 watts, and we are switching it off when we are consuming about 1,000 watts from the grid. And then we still have the battery and the Ohmpilot with a 6 kilowatt heating element. So we can see here that the pool pump is starting operation just around 8 a.m. and then finishing just about 11 a.m. At which point then the second load is taking over. and consuming the available excess, which is the electric car, as you can see here. So we can see here we have some consumption outside of what is available as far as PV production is concerned, and therefore here we are turning the EV off as far as charging is concerned. However, we still have the availability of surplus from time to time, and all this surplus is then divided between the battery storage and the Ohmpilot for generating hot water. So in this case, we can see that by intelligently utilizing or managing the loads that are connected to your network, then you can use as much PV power as possible and increase your self-sufficiency significantly. So to increase therefore the self-consumption, we have three key options. We have thermal storage, we have e-mobility, and battery storage. So in a typical PV system, this would be the normal production curve, so that we have starting from morning to midday, where we have the highest irradiation and therefore maximum production from your PV system, all the way to the evening. With the presence of a smart meter, Fronius smart meter, we can see what is the portion of consumption throughout the day, but more importantly, what is being consumed during the period when you have PV production. So as you can see, we have what is power to the grid, which would mean for our case, this would be excess power. This in yellow here is power to the battery, and in black here is what is consumed directly. And then the black line shows us consumption during the day and night. And then the orange line is the battery state of charge, and then the battery operational state. So how can you increase self-consumption? This can be done in three ways: shifting loads. So if some loads are probably operating outside of PV production, you can decide to shift when these loads are operating. You can also do load management that we have just looked at to ensure that some specific loads are only active when you have surplus energy available in the network. And then you can also do stepless control of the surplus power, which can be directed for hot water generation, can be done for EV charging as well as battery storage. But therefore, also the motivation, even for areas where exporting PV power to the grid is possible, is that over time, the energy supply tariff from the grid has been going up. But if you look at the contrast, the feed-in tariff has been dropping. So you can see you have a feed-in tariff of about 5 cents and a grid supply tariff of 22, which means that there is quite a difference in terms of the benefits that you get by using grid tariff as opposed to feeding your solar power to the grid. So for thermal storage purposes, we have a very specific gadget that we refer to as the Fronius Ohmpilot. And this can be used for increasing your self-consumption by stepless control of heating sources. And application is only for ohmic consumers. So here ohmic means that whichever heating appliances you're going to use should not have electronic parts in them, because there will be stepless supply of power to by the Ohmpilot. The Ohmpilot can control anything from 0 to 9 kilowatt. It can be 0 to or 3-phase. So in single phase up to 3 kilowatt, and then in 3-phase a maximum of 9 kilowatts. You can also do 1 or 2 heating elements, and communication is quite easy. It can be done by LAN, WLAN, then LAN or Modbus RTU. So it's also very possible to integrate the Ohmpilot into already existing heating systems, and you're able to retrofit the Ohmpilot to maximize or generate even more water for you. In terms of the working principle, stepless control of surplus power, you would require this component for the Ohmpilot. You just need a Fronius inverter with a data manager 2.0 and up. And then the Fronius smart meter, you require a Fronius Ohmpilot, and then a temperature sensor, which says here optional, but I would say it's actually a very important part of it, because it allows you to see the water temperature and monitor that also in SolarWeb. So we can see here that normally, if you assume that you have a production of about 1,500 watts and your loads are consuming 1,000 watts from that, you have a balance of 500 watts that can be fed to the grid if this is allowed. And if this is not allowed, then the most reasonable thing to do would be to find a way to utilize this excess energy. And one of the ways to do this would be something like an Ohmpilot to heat your water. When it comes to hot water generation, just for your understanding, we can look at an example here of a 4-person household with a 300-liter water tank and a PV system of about 5 kilowatt peak installed. For this family to be able to generate about 150 liters of hot water at 40 degrees, they would require about 5 kilowatt hours of energy. And this would mean that this is the minimum power supply during cloudy days. But for the entire 300 liters of storage to be heated up to 60 degrees, it would require about 17 kilowatt hours for this particular function. And therefore, this is the maximum supply that would be required on sunny days. So as far as the day curve with load management plus the Ohmpilot, it would look like this. So we have the consumption of about 11 kilowatt hours here, as you can see. And these are directed to the Ohmpilot to generate about 200 liters of water. And then we have an energy management option here that we are able to manage an additional 12 kilowatt hours of energy using the digital IOs. So we have here a reflection of the consumption by the Ohmpilot and what is the other overall consumption day and night of this particular installation. So you can see here that we are able to generate the hot water that is required for this particular family within the period whereby we have PV production, and therefore using this kind of concept, you are able to offset what would be typically a lot of PV production or consumption from the grid. So control options, we already covered this, so there's no need to go through them again, but you have the possibility to do a control without a connection to the inverter. You have Fronius load management, whereby a connection is required using the digital IOs, and then a dynamic control of the surplus using something like Wattpilot or Ohmpilot. So at this point, I would like to hand over to my colleague, Byron, to take over and do the last part of the presentation. Byron?
Thanks, David. So I'm going to be starting with the e-mobility side. So this is using our Fronius Wattpilot. So the Fronius Wattpilot is available in 2 variations. This is our EV charging solution. So you got the Wattpilot Go and also the Wattpilot Home variation. From the Wattpilot variations, you got the Wattpilot Go 11J and the 22J. So this means that its maximum charging power is 11 kilowatt for the 11J and then 22 for the 22J. It's an AC connection, so it uses a CE16 plug raid, so 5 pin, including the neutral wire. The exact same applies to the 22 variant, and it's got a nominal current of 6 to 16 amp, single phase or 3-phase, and then with the Go 22J, you got a much higher current, so from 6 all the way up to 32 amps, either from single or by the 3-phase. And then on the home variation, you've got it's a maximum size of only 11 kilowatt, 3-phase, so 3-core, normally physical earth, 400 volt, all the way to 230, for example, and then from 6 only to 16 amp. So it's very similar to the Go variation, except it is a physical wall mounted unit. So the standard scope of delivery. So this is normally when your Wattpilot is delivered. So you'll get the mounting bracket, which includes the screws and the dowels for it. The Wattpilot Go or Home variation, depending on which one has been ordered. You'll also get a micro fuse replacement. So only use the original micro fuses when using the units. Do not replace with an aftermarket fuse, for example. for section 4, so this is the metal bracket for theft protection. So it's only the bracket itself and not the padlock. So it's just a simple locking bracket that you'll then fix to the wall. So this prevents anyone from simply unplugging the unit and leaving with the unit. You also get an RFID reset card as well as ID chips. And then also what is included is your quick start guide for your Ohmpilot. Optional accessories. So you can get a Fronius branded type 2 cable, which is a 5-meter cable recommended at 32 amp for the 22 kilowatt variation of Ohmpilots that we have available. You can also order additional ID chips. So you can order an additional 10 ID chips for your Ohmpilot, an additional mounting plate for the Go devices. So with the Go devices, you could normally have one mounted at your home, for example, and have another bracket installed at your office. So you can then therefore charge at home and charge at the office. You just simply order the additional mounting plate. Another optional accessory is the adapters for the Go 22, which includes the CE Red 22, all the way to the 16 red, blue, and your Shuko 16 amp plugs. This also applies to the Ohmpilot Go 11, which is a normally CE Red 16. So this is 32 amp red and then the blue 16 amp, and then as well as your Seiko 16 amp plugs. So this is just a functional overview of how your system would interact with your Ohmpilot. So you'll have a normal system with your Fronius inverter and your original grid meter, as well as your normal loads that are covered by your Fronius inverter. So what will happen is your Fronius Ohmpilot Go is just an additional add-on feature. So it ties directly into the system itself. It doesn't need additional cable running from the inverter, for example. It can tie into an existing system. It'll just have to have a requirement of internet connection. So this is normally done WLAN to the unit from your router, for example. And that's one of the major requirements with using the Ohmpilot. The same can be used with the Fronius hybrid inverters, so our Gen 24 series, as well as the Snap inverter series. So with the Ohmpilot, you will then require the Solar Ohmpilot app. So it is a standalone app, so it allows you connection via the box access point or via the integrated network. So you can do correct connection directly over the internet for remote access. So if you are sitting at the office, for example, you can do changes to your Ohmpilot Go on the go. You can also do useful for commissioning of the unit, visualization, so you can see how much exactly your Ohmpilot is consuming from PV, for example, or from the grid itself. And then as well as your setting options. So this gives you a lot of variability on what charging you want to do. So you've got different charging modes. You can set your amperage, for example. What's also nice is that it gives you access on your Ohmpilot from all around the world via the app. So charging with the Ohmpilot. So you get simple charging. So this is charging with a preset current. So for example, the 16 amp fixed. You can self-adjust it in increments. So you can choose the level at which you want to charge at what amperage, and then slowly and gently or as quickly as possible, for example. You also have surplus or flexible electricity tariffs that are not taken into account in this charging mode. So charging with grid connection is necessary with this. To adjust the current, you can simply use the button to adjust the current amperage that you are charging with by simply pressing on the button and holding. And the LED indicators will visually tell you at what amperage you are currently charging at. So charging with variable energy tariffs. So even if there's no available PV, the electric car can charge cost effectively overnight with variable electricity tariffs. So this is especially for regions where it is cheaper to charge from 2 a.m. to 4 a.m., for example. This feature is possible so that you can then charge at the cheapest tariff in a sense. Please note that this feature is only available in regions where it is possible to have variable energy tariffs per hour. Another additional way of charging is via the PV surplus charging. So it's intelligent use of your energy surplus rather than feeding it back into the grid. So the charging process can be controlled in single amperage steps. Use of the PV surplus. So if you have a surplus of 1.38 kilowatt all the way up to 22 kilowatts, it's possible to then push that power back into your Ohmpilot instead of being pushed back into the grid. And also nice feature is that it's fully automatic. So you get 1 to 3 phase switchover. So surplus charging, so how does it work? So is part of the next ride or eco mode. Modes is the surplus charging. So it defines the threshold value for the start of the respective charging, so either single phase or 3 phase. This allows the switching between the single with 1 and 3 phases charging is possible. So regulation possible in 1 amp steps. So on 230 watt single phase and also at 390 watt 3 phase. So here you can see the min charging power for the single phase and then your min charging power for the 3 phase. So this is the excess power that needs to be available. And then automatic switchover from 1 to 3 phase charge. The next way to charge is the cheapest mode, which is our eco mode. So this is a combination of the PV surplus and charging with the variable energy tariffs. So this is when the Ohmpilot will use high self-consumption rates of PV, faster absorption, and cheaper energy for the electrical vehicle. Our next trip mode, so this is get to your destination as cheaply as possible. So in the morning, you would set that you need to achieve 60 kilometers tomorrow is your total distance, and you need to leave the house at 7 a.m., for example, for the lowest price. This is not an issue with our next trip mode. So you can specify the distance that should be charged is defined. So what it'll do is it'll take into account the kilowatt hour of the size battery if in your EV vehicle. And then from there, it will then determine on what kilowatt should be available for you to achieve that distance. So the PV surplus energy or the variable electrifier tariff is used for this. And also to ensure charging the EV is always charged with the desired amount of energy, even in spite of higher costs. So this is when it'll take into account that it is priority in a sense and not really focusing on trying to do the cheapest charge. Next section we'll talk about is our Gen 24 Plus battery storage. So our Gen 24 Plus, so it's uniquely versatile. So it's available in 2 different variations. So you got the Fronius Primo Gen 24 Plus and then the Fronius Simo Gen 24 Plus. So the Primo is the single phase variation and the Simo is the 3 phase. This Primo is available in power classes from 3 to 6 kilowatt and the 3 phase from 3 all the way to 10 kilowatt. Both have 2 MPPT input, PV inputs, and 1 battery input on each. So with the Fronius Gen 24 Plus, we've seen the highest efficiency with it, coupled with a BYD battery box. So a 94% efficiency, which is at the moment class leading. So Gen 24 Plus is again winner of 2022 and also recently 2022 testing. It also finished as the highest efficiency coupled with a BYD battery. So with the Gen 24, you can achieve full battery backup as well as BYD paralleling is an optional extra. So the storage cascading, so you got parallel operation of up to 3 storage units. This gives you the higher capacity that you can achieve is 57.96 kilowatt hours. This will give you full backup power capability, and then also parallel discharging or recharging, so multi-flow in a sense, with the BYD batteries. So for example, with the maximum backup power on the full backup side, so this is when you have a 3-phase backup power. So the overall supply of the entire household is achieved, and then maximum supply. The only thing is that the automatic switchover is anything up to 60 seconds. And then also you can cover full electrical load. So it can be single phase and 3-phase backup. And then maximum energy consumption. So again, mentioning the parallel discharging or multi-flow design. With the BYD batteries, they are lithium iron phosphate batteries. So they are retrofittable. So you can have a single power stack, which is 2.6 kilowatt hours, so the HVS, or the 2.8 kilowatt hour HVM steps. They are modular. So the BMS is modular in a sense that you can do multiple power stacks. So you can have 5.1 all the way up to 10.2 kilowatt hours. So that's anything from 2 to 4 modules with one BMS. And then with the HVM, you can have 11 up to 22.1 kilowatt hours. So this is anything from 4 to 8 modules on one BMS. It's an easy installation, so it's a ground mount. So it's got a ground mount plate that the inverters, the batteries will sit on, apologies. And this also gives you easy commissioning with the Gen 24, as both are integrated to work. So mentioning the multi-flow technology. So this is when you have your PV generation that is then fed directly through to your inverter, which is then helping to supply the loads. And if additional energy is there, you can then feed back directly into the grid, as well as doing your battery charging at the same time. You can also pull directly from the battery storage to help feed additional loads if the loads are too great for your PV generation to then compensate for, as well as also using your grid supply to help recharge the battery during discharge. You can then also have an AC coupled solution, which is where you're using an additional PV generator to help feed loads back in or to help recharge the battery. So this is just an example of 3-phase backup power with a full backup. So if you've lost the grid, for example, grid has failed, you're then relying entirely on your Gen 24 and your BYD battery storage. You'll have your backup switch that is then opened. This will allow for your PV generation to then recharge your battery, and then as well as to supply your grid, your loads that are being demanded, as well as using the battery to also help feed those additional loads. So recharging the battery in backup mode. So this is the multi-flow. So this is when you're using 2 additional inverters to recharge the battery itself. So it's similar to an AC coupled solution. So this is possible with the BYD premium HVS or HVM batteries itself. So this is when you'll have a Gen 24 with BYD and then have a smaller Fronius snap inverter also to help recharge and act as an additional PV generation. So also using your existing PV system, so charging from the AC side is also possible. So just a bit of technical data on the full backup power. So on the Fronius Primo Gen 24, so from power class of 3 to 6, so you got a nominal power of 3 to 6.2 kVA, and then power per phase is obviously 3 to 6.2, and then your maximum discharging current is 22 amps. Whereas for the Fronius Simo Gen 24 Plus, so power class 6, 8, all the way up to 10, so you got a 6 to 8 and 10 kVA, which is 12 kilowatt kVA, up to 5 seconds. And this also gives you a power per phase of 3.68 or 4.1 kVA of up to 5 seconds to allow for a higher draw current to come through. Also, your maximum discharging current is also again 22 amps. So a calculation of the discharging power. So this is when you'll use your 22 amps multiplied by your battery voltage. So either the HVM or HVS. So this can either be 200 all the way to 400 volt. So this can give you a value of 4.4 or to 8.8 kilowatt. So the charging and discharging, so up to 9 kilowatts even during a grid outage. So this is just stating your maximum of discharging and charging of the HVM or HVS batteries along with the inverter capability. So on the Fronius, so for example, on the Fronius Simo Gen 2410 Plus, we can see that the maximum is 9 kilowatts with the HVS. And then on the 22.1 HVM batteries, we can also achieve the 9 kilowatt. So the BYD storage, so the combination matrix. So this is just showing you which batteries are compatible with which inverter. So with the Primo Gen 24 Plus, the HVS 7.7 is the maximum size on the HVS that you can have on the Primo, whereas you can have the HVS up to the 10.2 variation on the Simo. With the HVM, you can have 11 all the way up to 19 kilowatts available for the Primo Gen 24 Plus, and then on the Simo, you can have from HVM 11 all the way up to 22.1 on the HVM side. So it's just a combination again. So attention, always the combination of 3 by the 22.1 is not possible. As mentioned earlier, the highest capacity available is 57.96 kilowatt hours. So this is making a combination of your battery banks in a sense. So the highest capability that you can achieve is the 57.96 kilowatt hours. For further information, these are our supported regions. So these are the regions supported by David and also by my colleague Cyprian, and then as well as myself. It's just a short demonstration of our Fronius system partners that we have. So local sales partners and level 1 of support, and then also your stock replacement parts in different regions. The recordings are available on our homepage, so operation and installation instructions as well as available at fronius.en/downloads. On our YouTube channel, you can find our how-to and installation videos, as well as webinar recordings, and also our Sub-Sahara African playlist. For your Fronius Energy team, so you got for any technical support, trainings, Sales International, and after-sales service, as well as my colleagues and myself, our respective emails and phone numbers if you do wish to contact us.